Okay, the question, what is the Pythagorean theorem? Is an interesting question because you've internalized it as a squared plus b squared equals c squared. That's what you've internalized. That's what you've memorized. Without context to those letters, that's just a random equation. It's a random equation that typically signifies that A and B are the two legs of a right triangle and C is the hypotenuse of a right triangle. But a squared plus b squared equals c squared itself is not the Pythagorean theorem. A squared plus b squared equals c squared is a pointless equation unless we give context to the variables. Okay, unless we give context to those variables. I'm being really specific on this because here's the biggest problem folks have with Pythagorean theorem. They don't know that they have to put the hypotenuse on the side of the equal sign all by itself, squared. People will put random values in for C because they feel like a number should go in for C. Or people will just choose not to put numbers in for C. Like if I give you two sides of a right triangle, lots of people think it's completely appropriate to just put them in for A and B and then calculate C. But there's lots of people that don't understand that C has to be the hypotenuse. If I give you a number that represents the hypotenuse, that has to go in the C spot, no matter what I call it. Okay? If I give you a variable, if I give you anything, it has to go into the C spot. The same thing is, what else am I going to say? Just got to be super careful with that. Check this out. Part of these directions say round to the nearest tenth if necessary. Yeah. In this particular context, the only problems that it's necessary to do that in is 6 and 6. What's the distinguishing characteristic that makes number 6, makes it necessary to round in number 6? 4.5. It starts, there's a number in there that starts as a decimal that requires us to round. Okay? None of the other ones start as decimals, so none of the other answers should end as decimals. Right? Make sense? Okay. Yeah. You can have fractions. In these cases, you won't. So, numeral 1. Let's pull back. What's the distinguishing characteristic of being able to use the Pythagorean theorem? What has to be true for you to be able to use the Pythagorean theorem? A particular shape has to be a right triangle for you to be able to use the Pythagorean theorem to calculate sides. All right? Absolutely has to be a right triangle. There has to be a right angle, right, for you to use it to calculate a side measurement. You also have to have 2 of the 3 sides to do it. Okay? All right, so number 1. Which one's the hypotenuse? C? Is it because it's called C? Why is C the hypotenuse? It's the longest, and what else? It's slanted. It's slanted. It's opposite the right angle. It's across the triangle from the right angle. Okay? So when we do this, we get 4 squared plus 3 squared equals c squared. 4 squared is 16, and a good game. 3 squared is 9. 16 plus 9 is 25 equals c squared. Have we found out the length of the hypotenuse? The length of the hypotenuse, 25? No. We would want to square root both sides, and we get 5. The length of this hypotenuse is 5. Okay? Yeah. Yeah. Great question. Are you guys ever going to get stuck with a situation that can't be square rooted? Let's look at number 3. Let's skip this one. Let's look at number 3 together. Which one's the hypotenuse? So which goes on the side of the equal sign by itself? Place that first. Got that? Okay? We go for it. Go for it. Go for it. 20 squared is 400. I say it like that because I'm cool. 33 squared is 1,089. To solve this little equation, you need to subtract 400 from both sides. 1089 minus 400 is 689. Solve this, you need to square root both sides of the equation. What is 689 square rooted? 26 point blah, 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 wah, 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 wah. Right now, that is a radical that is not a perfect square, and I would like you to reduce the radical. Who knows how to reduce radicals? It's Christmas time-ish. I mean, it's holiday time, and there are holiday trees available. As a reminder, maybe, a little refresher, hint, holiday trees, anyone? Little factor tree going on, little factor tree. You can do a little factor tree. We pull out the prime factors, right? We look for sets of 2. It's feeling pretty good about now. I'll tell you that this one in particular divides by, what, 13 and 53. And that's not fair right now because that just doesn't reduce any further. So this one's actually done. You can't reduce it any further. This is exciting. Exciting. Let's do, yeah, this is exciting. Let's do 4. Oh, yeah, 4. What's the hypotenuse? 8, B, or 9? Why do we know it's 9? It would have been funny if I would have said 8, B, or 9, and you said 9, and I said, stop telling me no. That was a German joke, wasn't it? It was a good one. I'm going to use that next hour. It'll be funny. So 64 plus b squared equals 81, right? Minus 64. B squared is 17. Square root both sides. You get b equals square root 17. 17 is a prime number, so that's done. Oh, that's nice. Let's do 5, though. 5's fun. Let's do 5. It's exciting. So, what's the hypotenuse? 28. Why is that important? That's opposite the right angle, and that goes on the equal side by itself. And we get 10 squared plus a squared. By the way, it doesn't matter. A or B are both legs. It doesn't matter their location, you know? Doesn't matter. So that's 100. 100. And I say that because I'm cool. 28 squared. 784. I know I don't have that memorized. That's kind of sad. So we get a squared equals 684. Is it appropriate to end there? We want what the measure of a is. We want the length. So we square root both sides. All right, let's do some, we're not going to do 6. Divide by 2. 684. I like to divide out the lowest primes, like 2, 342. Oh, I'm going to take another 2 out. That'll be exciting. 2 and 171. Oh, this is getting weird. 171. What is it divided by? I like 3, right? 3 and what? 57. What is 57 divide out? 3 and what? 3 and 19. It's 19. 19's prime. So how do we do this? What stuff goes outside the radical, stuff goes inside the radical? You remember that part? What stuff goes where and how many of which? Aha. What do you think? 2 of 1, it goes outside, right? That's what I think, right? 2 of 1, this goes outside and goes out as a multiply, and then this guy, if there's one of them, that gets tucked underneath. 6 square root 19. Yes. I'm loving it, McDonald's. Let's do 7. Which one's the hypotenuse? C. Good. That's the one that goes on the side. Not because it's C, just because. Would that really mess you up if I put C as a leg? Really? Would that blow your mind? Wouldn't be. Maybe I'll do that on the warm up tomorrow. $34. Square root both sides, right? 34 to 17. Not really feeling like 17 can reduce. It seems to be a little prime. So that's done. Let's do numero 9. Champion finish with 9. What's we're gonna do the lower part too. So what's the hypotenuse? Do you find it annoying that I keep asking that? So this guy, so you get 24 squared. Does that really mess you up that I wrote B first? It doesn't really matter where B and A, which, you know, what matters is the hypotenuse. And what matters is that it's actually a right triangle. I don't know what 24 squared is. Sorry, guys. What's 24 squared? 576, really? That's exciting. Who wrote 20? What? I'm doing 9. I'm going to do 9er. Square rootify it. All right, now factor tree. It kind of reminds me of Christmas. I like Christmas. Reminds me of Santa. I like Santa. Oh, what you gonna divide out of this? Oh. I don't know why you didn't say 5, because 5's like, whoa, it ends in 5 or 0. Divided by 5. But we can divide by 3 too. Whatever floats your boat. Works for me. This guy comes out as 2. This guy comes out as a 3. These 2 stay in. You're not allowed out. All right, so that's our value for B. All right, now here's the interesting part. We're going to skip this stuff because it's just like the top stuff. We're going to go down up in here. Oh my gosh. Thank you. So in these questions, it says the lengths of the sides of a triangle are given. Determine whether each triangle is a right triangle. What? Okay. So here's the scenario. Here's the scenario, not Mario. Here's the scenario. The scenario is we're given three sides of a triangle, and we don't know whether it's a right triangle. We're going to determine whether it is. How so? Draw a picture. Do you guys want to do a construction? You don't? Are you sure? Okay. We won't do constructions. All right? Instead of doing some constructions, what's another method? Yes, sir. What about the measurements of the sides? Okay, you could determine the type of triangle in terms of the sides, isosceles, scalene, and equilateral, but we actually want the type of the triangle in terms of the angles, like a right triangle. Make sense? Not a bad connection, though. Not a bad thought. Yeah. If all those equal 90, like 3 plus 4 plus 5 equal 90. Yeah, I know why you're thinking 90 because of the right triangle.
Maybe do like the two legs and like do the a squared plus b squared plus 2 legs and then equals
If a triangle is a right triangle, the sides work with the Pythagorean theorem. That's a fact. That's part of the Pythagorean theorem. That's true. If three sides do not work in the Pythagorean theorem, it is not a right triangle. Does that make sense? Work. Well, we're going to put the numbers in the Pythagorean equation, see if it makes a true statement. If it makes a true statement, it works. If it's false, it doesn't work. Let's do 18, 19 before you guys leave. Which one's the hypotenuse? Which ones would be the hypotenuse if there was one? 5. So that goes over here. Why is 5? It's what Victor said earlier. It's the longest. The longest would be the hypotenuse if it was. So does this work? 9 plus 16, does that equal 25? Yes. So this is, yes, a right triangle. Okay? Let's look at 19. 19, which one would be the hypotenuse if it was a hypotenuse? 2. So we get 2 squared there, 1 squared plus 1 squared on the other side. Is that true? 1 plus 1 equals 4. 2 equals 4. That's nonsense. Nope. Not a right triangle. Okay, do you get the logic on that? Pythagorean theorem works? Yes. Pythagorean theorem does not work? No. Cool? Do your homework for real. You guys did a great job coming back and doing your homework. I'm proud of most of you.